Hello and welcome to session 9, Shared File Systems. In this session, what we're going to look at is just a little bit of background as to the way the shared file systems fit in, and then we're going to quickly move on to doing the client and server installation of those. And right at the end, we're just going to look at some alternative deployment, something to think about going forward in the future, because when we've actually looked at this deployment, it's not the only solution. It's a step towards a bigger solution. This is just putting in a shared resource to the web architecture. That's all. Okay, a little bit of context. When we've got large web services, what we have to do is we have to eliminate the need to upload certain files multiple times. What we want to do is we want to do something once, but does it for all the servers. So when it comes to large database-driven applications on the web, generally there's a shared storage area and a shared database. So those two resources allow us to store content, which is shared across the servers, but also metadata about information that is uploaded as well. And very often that metadata has pointers to the actual shared content. Now, when I say it's shared content, what I'm actually meaning are things like images, music files, videos, any kind of document that isn't part of the application. It's data going into the application. So, as I say, image files, music, videos, documents, those kinds of things, as long as it's not part of the application. So the idea is they are centralized. Now, that is the way it should always be done, really. So the application files, which are generally the PHP files and the HTML files, are stored on each of the individual web servers. So each web server has its own copy, and that sort of improves performance. We'll come on to that later on. But then the content is actually shared, and the content is the information, like metadata, and the files, as we've already said. Now, some applications, the way they're developed, don't allow us to do that very easily. A very popular one is WordPress, and that is because of the way it stores themes. They're stored as PHP files, but they need to be stored in shared content, which is a bit unusual. But there are ways and means of actually managing that. Instead of just having one set of sort of content store, have multiple content stores that are optimized specifically for sharing the application. But the way we're developing it, we're going to look at it as a distributed system, which we would develop into. So basically, the way you develop the application should take into consideration the architecture you're going to be building on. In effect, what we're saying here is the web server farm, where all the web servers are, basically have access to a shared NFS file storage area and probably a database as well. All of the application files would be stored on the web server. All of the metadata associated with the information that is actually added to the website, and usually the stored location of things like images and documents, would be in the database, and then the actual file storage itself would sit there as well, and that would be where the content is uploaded. So if a document was uploaded to, say, this first web server, it wouldn't be stored locally, it would be stored on the shared storage, and that would make it automatically available to all of the other web servers within the farm. Now, when it comes to deploying the security, when it comes to deploying NFS, one of the things we need to take into consideration is security. There's probably going to be more than just the web servers running on that network. So there needs to be some kind of mechanism of securing access to the file storage. And there's several ways this can be done. Now, it's a massive topic. So what I would do is I would refer you to this URL, where there's quite a nice article here about the different mechanisms you can use to secure your NFS file storage. It'll cover things like LDAP. You could even use something like Samba. Using credential files, LDAP will use usernames and passwords. You could even use the internal user ID, group ID authentication, because if it's all done on a Linux environment, you can share the IDs across servers. We are going to use RDNS. We've been looking at domain name services at the beginning, so what we're going to do is we're actually going to specifically focus on RDNS and using RDNS as the authentication mechanism. If you remember when we were looking at RDNS, we discussed the way a mail server works, where when you connect to the server, you can use a reverse lookup to validate where something came from. That's exactly what this is going to do. Basically, you actually reverse look up for a URL, and then you can validate the URL to make sure it's genuinely coming from where you expect. As I say, we'll come on to that in a moment as well. So, specifically, what is content storage and where would it sit in a normal full-blown architecture? Well, I've said before, it sits with the web server farm being able to access it. However, if we were going for a full-blown deployment, and this was actually being put out as a public network, what you would usually have is you would normally have the web servers sat on two networks. One of the networks would be the internal network where everything is stored, and for instance the metadata and the files, and then the public facing side is where the actual client machines or browsers would connect to it. Now interestingly, when we talk about web, we tend to talk about the web servers and the clients being the browsers. When we're talking about shared content, we've slightly shifted that down a layer, because the web server farm, where the web servers are, they will actually be clients to the actual NFS storage, and the NFS storage is a server. So we've got server to client across those two layers. There's many ways this can be done, but that's outside the scope of the module. But the kinds of things that are done here are things like mapping through NATed networks, etc. So this would be inside a network, and then you would have dual network cards, and then you would have your back-end storage on some kind of administrative network. But that's a bit beyond the scope of what we're going to do. What we want to do is actually just get these technologies running in this module. Now, when it comes to actually setting up the NFS server, now this is definitely the server side of it, not the client. Just like most applications we've needed on our Linux environment, specifically using Ubuntu, we can actually pull in these applications from the Ubuntu repository. And to do that, we simply use the apt command. So sudo apt install NFS kernel server will actually bring down that server software, set it up and install it on our server. So setting up the server basically means putting the NFS server software onto the box and then configuring it. Now, something I will remind you of, and that is, don't forget, as and when you're working with servers, you should be updating and upgrading them regularly. Again, as I said before, this is something you would normally do on test boxes before production, but we'll just do it straight onto our production boxes because we're just doing this in an academic environment. So, install NFS kernel server. When we do that, it will work out any dependencies there are on other packages, and it will bring those down and install them too. So it will go through, it'll do the installation, comes to the end, and it should stop and we're ready. NFS is installed. And interestingly, it does start it by default, but the configuration has nothing being shared, so that doesn't really impact on us. So what we need to do to get it all up and running is we need to make entries in the etc exports file. Unfortunately, as it goes through, it just says it's created that file for us. So on the server, it's actually already pre-created empty configuration files for us to start configuring the sharing of files from the NFS server. Now, that configuration file is just a text file, just like many of the configuration components in Linux. And the actual file itself is called exports and is located in the etc folder. Now that allows us on the server to say, given a certain directory, that directory is now available for somebody to mount on their file system. And there's two main ways we can do that, which we'll look at shortly. But first of all, what we need to do is actually get a directory on our actual server, export it, and export it with the correct permissions. Now, the simplest way to actually expose a folder through NFS is simply to export it, and using the asterisk, that means export this to anybody who wants it. This is very insecure. In effect, what it says is allow any client on the network to connect to that folder on the actual NFS box. So with this one, that would allow anybody to connect to the home folder with full read-write permissions. Now it's worth pointing out, after that star and the open bracket and the options, and we'll discuss a little bit more about the options in a minute, there is no space. If you leave a space, it will automatically allow everybody, even when we start trying to put in our DNS authentication. So there is no space after the star. It expects a continuous string in there for that to work. So to set this up with no security, which is always a good test bed, when you first set up your NFS, it's a good idea to do it this way. All you have to do is export the folder you want, specify a star, and then how you want to export it. And you can export as many folders as you want. Now, the way it works is, in the actual folder, the exports folder, all you do is specify the directory path on the actual server itself, and then you specify the security option. Originally, we just said star, and then we put in brackets the options for the export. If we want to use our DNS, all we have to do is add in the actual URL that we want to be allowed to connect to this. Now, when I say the URL, it's the URL defined using a regular expression. Now, to use regular expressions, a question mark represents a single character. A star represents any number of characters. So in effect, if we said www star, that would mean anything with www at the beginning, anything up to a dot, and then student.co.uk. So if we put that in, it would match www1, 2, even www32 with 2 characters. So using this notation, we can actually say to the server, use our DNS. So how does that work? Well, when you try and mount up this folder, the IP address you use will be reverse looked up by the NFS server. And when it does the reverse lookup, it will get, as we've seen before with our DNS, a name, a fully qualified domain name, or several fully qualified domain names. They are then matched to this regular expression. And if it matches, you're allowed to connect. If it fails to match, you're not allowed to connect. So it's a very simple way of using RDNS as a mechanism to implement security in an NFS implementation. And that's what we're going to use. Now again, notice there's no space between that expression and the options. Basically, the URL is being used by NFS. So how does it do a reverse lookup? Well, if you wanted to do a reverse lookup and to be able to check all of these regular expressions in the exports file, you must make sure that the NFS server is actually using the DNS server that holds that RDNS zone. So this is quite an odd one because we're now linking services. And if you remember, we've said right at the beginning, when we put in network services, we try and keep them independent. This is one of those occasions where we're actually going to use the service. So instead of it being independent, we're actually going to have the NFS service using DNS. So we have to link the two together. Because we're linking them together, we can just start using URLs where we'd normally use IP addresses. We can use URLs now. However, it does give us a potential area where we could have a point of failure, because if the DNS service goes down, NFS will stop working. But that said, if the NFS service goes down, if the DNS service goes down, you've got quite a few problems anyway. So it's one of these ones where, yes, we try and keep them separated, but in this case, because we're going to use a service, we're going to actually link to it. So on the NFS server, when we set up its IP settings, we must make sure we set our DNS settings to point to the main server, the main DNS architecture. So after the host name, what we have is that comma separated list of options. And there's quite a few options we can put in there. And they all have different levels of control over what happens. We've got things like secure. And what that will do is that will make sure that the NFS server will only accept connections on ports above 1024. To give a little bit of history to that, or a little bit of, or flesh out the bones a little bit, network services, anything that runs below port 1024 can only be started or used if we actually have super user privileges. Now that in itself has a small problem, because we can only start it up with super user privileges. The level of security it has might be a little bit more than we want. We can also set it up as insecure, and if we do that, people could connect to it, start up that service and connect to it on a port above and beyond 1024. Now that means any user could set the service up, so that's not such a good idea. So in generally, we would keep it to being a secure service that runs below port 1024. In fact, if you don't specify secure, that's what it will do automatically. The other two options, and we've seen these two already, are RO and RW. RO means when you share that directory out, it is shared with read-only privileges. That's it. If you don't specify read-only or read-write, it will default to read-only. The other option is obviously read-write. Now, in a content management system, like we may well be building on top of this architecture, we obviously want the share to be writable, so that as files are uploaded to the web server, they can be dropped onto the NFS server. So we are pretty much going to always use read-write. Read-only is tend to be used when you've got shared download facilities with no upload facility whatsoever. But with the kind of work we're going to be doing, read-write is the way we would do it. We also have things like squash root and no squash root, and that's to do with the way the user IDs in the system are managed. With squash root, basically everything that connects to the box uses the user ID of -2, which means nobody, the nobody group. What that does is it prevents you putting things onto the server and giving them administrative privileges, setting them with the root user ID or group ID. So it prevents that. So root squash is just a way of taking away root privileges on the mount. And no root squash is obviously the opposite, and it allows, if you connect with user ID 0, as in you connect as the root user, you can drop files onto the server as root user. Something you would very, very rarely do. In fact, I can't think of a reason to do it. So you would probably want to go with root squash. You've also got link relative and link absolute, and that's to do with the directory paths as to where you can navigate. Again, it's not something we're going to actually be working very much with. So the usual, we would allow the default behavior, which would be link absolute. It just prevents, given a mount point, being able to do a relative path to try and get somewhere else on the box. It just prevents you doing that. We've also got alternative authentication mechanisms with map identity, whereby what you can do is the user IDs and the group IDs between the server and the clients are synchronized. And what will happen then is whatever account you attach with, that is the actual account ID that would be allocated to the servers. And the other one is, it is possible if the user IDs and group IDs are not synchronized between machines, you can use a map daemon. And what that will do is you can actually create a link between the accounts so that you can have different IDs but still get the same privileges on different boxes. You've also got map static, whereby what you can do is you could actually do that without the daemons communicating and simply doing it yourself just by writing it into a text file, hard coding it in to say this user maps to another user. And the other kinds of things you can do, you could map to a NIS, which is a network information service, a bit like having some kind of LDAP, etc., an LDAP server where you can use username password authentication to get user IDs. But again, that's not something we're going to use in our implementation. And again, you can actually come in as an anonymous account as well. So there's a load of flags we can use. We're just going to use a minimal amount. We just want this to be up and running with a little bit of security using our DNS. Now, when we do that configuration file, first thing we're going to want to do is have that activated. Now, the only way to activate it is to restart the service. Once you restart the service, those configuration files are loaded and the exports will take place. And to do that, we just use the systemctl command, tell it to restart the NFS service. The service will restart and load those configuration files. And that will then initiate the share. So it's now sat on the network and waiting for connections to come in. If when you've actually done that restart, if you want to see if the shares are active, just use the show mount -e localhost file, obviously with sudo, and what you will get is a list of all the file systems that are exported. So that's a quick way of just checking to make sure the configuration you've done is correct. You've also got the syslog to see if you've got any errors. Now, when it comes to actually getting the clients to connect to this, so we've set all our directories up, we've created them, we've shared them out, we've restarted the server, so they're now sat on the network waiting. Well, very often what happens is it's mounted as a subdirectory within the home directory of the actual website. So you'll very often see files shared out from networks, on web servers as /static. That's a very common way of doing it. And inside /static, what will be is a list of like all the files that are commonly uploaded. Now, in the case of our servers, we can create that folder anywhere we want, but the idea is when you put a file in it, it's shared or commoned up across all of the servers. So you upload once and you can use it across many. Please remember though, that area is not so you can make it easy to transfer applications. If you put all the PHP files, etc. in there, what you will be doing is you will end up creating an overhead on the network, because every server has to go to the NFS server just to read the application files, even if all it is doing is pulling some data from a database to display what appears to be a static page, just lookup pages. So PHP files should be loaded locally. That means you don't get network traffic. And also it means when those files are compiled, the actual objects that are created with respect to PHP, with the mod PHP installed, stay local to each machine and are therefore loaded more quickly. The other thing it allows us to do is if the applications are stored on separate machines, we know we can change the DNS to change which machines are being shared out. So we can do that, isolate a machine, and it can be updated in isolation. So if you common up the application files, you can't do this slow migration of updates and checking and swapping in and out servers. Whereas if we keep it to the separate machines, we improve the performance and we give ourselves more flexibility when it comes to the maintenance of everything. So how do we actually do this deployment then? Well, basically what we're going to do is we install that and we set it up. And now what we need to do is these web servers now have to become clients. So the hard bit's done with sharing this out and securing it using the actual RDNS. These machines are already set up probably using RDNS. That's what we did last week with it. So what we want is we want these machines now to become NFS clients and to mount up those shared folders so that we common up the file area for shared files. Now, just like on the server, we actually installed from the repository the server component. From the client perspective, we don't want the NFS server, we actually want the NFS common, which contains all of the client-based applications. Now, interestingly, when you install the server, the NFS kernel server, it automatically installs the common component as well. But when it comes to the client machines, the web servers, we don't want the server software on there. It's just an overhead that's not necessary. We just want the NFS common, which gives us the client that allows us to connect the server in. Again, when we install it, what it will do is it will look for dependencies, etc., and then off it will go and do the installation. And hopefully when it's done, it just fires it off and it's running. Job done. What we now need to do is we now need to actually use that NFS. Now, interestingly, NFS, when it comes to a client machine, is almost just like a file system. So it's just like your ext4 or your NTFS. That's how it sees it. What happens in the back of it is that it actually uses network communications rather than file communications. And there is a little caveat we need to look at on that when it comes to using that file system. Some of the things we shouldn't be doing or should be doing. So the NFS file systems, the way it works is on the server, all we did was create a folder and say, that's what I want to share. Now what we have to do on a client is we need to create what's called a mount point. And a mount point can be located anywhere. Now, the mount point is basically where we say that folder no longer belongs to this machine. It's actually on the network resource, which is the NFS server. When we actually mount that file system, what we're actually doing is saying that that point in the directory structure is now got in the file structure now has a network location. So no longer look in the hard drives, look to the network and actually communicate that way. Because of that, what you need to or should be very aware of is the folder that you set up as an NFS client as a mount point. Once the mount is made, you can no longer see what's inside that folder. The files sort of disappear. They haven't. What's happened is anything that goes to that folder is redirected to the network. If you unmount that folder, you can actually see the files that were there again. So it's just a caution. Be careful when you create mount points. It's best that you leave them empty, because once a mount is made, you can't see the files that are in that directory. To actually do the mounting, there's two ways of doing it. One of them is for temporary mounts, and the other is for permanent mounts when we want the server every time it boots. Sorry, the web server every time it boots to mount up the NFS shares. And the way we do that is through something called fstab. The mount command is something that allows us to test it and do it temporarily. So the two ways we can do it are temporary with mount and permanently using fstab, which is the file system table. So when we build it, we should always use the mount command before we start making anything permanent. To mount up the file share, what we have to do is specify the location that the actual server is and the location we want to actually mount the shared resource to. So a simple command of sudo mount, and then in this case what I've done is because I've got this all mounted up because I've got the network settings set up to use the same DNS server as the client machines that I've been using, nfs.student.co.uk is there, and the shared area I've got is var storage. So in the exports file, var storage is exported, and what I've done is I've exported it so that, let's say, anybody can mount it. The sudo mount command, the nfs.student.co.uk will be resolved and get an IP address, and that's where it will go to that server and ask for that folder. What it will then do is, if it's allowed, it will take that folder and mount it to var www html content. So in effect, var storage is the content folder now. If I then no longer wish to use that and wish to remove that mount or unmount it, I simply use the umount command. Now I'm unmounting it, but the command is umount. So if I go umount var html www content, in other words, the actual point in the directory structure, which is the mount point, that will then remove the NFS and I get back to the folder. So when you're building the architecture from scratch, when you've got one server, you'll probably set it up, you'll have the folder, you put the application in. If you then need to migrate to a distributed infrastructure, you would take the shared content area, put that onto the NFS, mount it up, and just move the contents. As simple as that. Then you could add additional servers in, and there shouldn't be an issue, which is one of the reasons you plan ahead. Now, the second way is the fstab, which stands for File System Table. And what that does is that allows us to actually mount systems at boot. Now, if it's a web server, that's a good option, because what you don't want to have to do is start up a web server, go in, manually mount it up, and then have the server available to the outside world. You want to put the server, automatically mount. However, think about what we're doing now, because we're starting to get some dependencies here. We're using the DNS for authentication, and the web servers need the NFS server. So DNS has to be running first, so that when the NFS server is up and running next, it can use it for our DNS authentication when the clients connect. So there's a boot sequence we've now generated on a web server farm. So the fstab is only editable with root privileges, so sudo, for when we want to edit it. And if we want to actually mount everything that is in there, we can with the mount command, but only as a super user. So sudo mount -a, that command will actually read the fstab file and mount everything. So after you've tested everything with mount to make sure it works, you can then set up the fstab, run the mount -a, and that's another way of testing to make sure all your syntax is right and you don't end up with services hanging while they're waiting for connections. So fstab, that allows us to automatically bring machines online and automatically mount up systems without us having to do anything. Now, the syntax is a little bit more complicated in the FS tab file, and that's because the automated file system mounting needs more information to know what to do. First of all, the first part of the entry would be the actual server. And in this case, instead of using an IP address, because of the dependencies, I'm just going to use a URL, so nfs.student.co.uk. The colon then separates the actual mount or the share that I want to use in this mount. So in the case of this one, I'm saying that on the server, we've got var storage in the exports file. So that's what I want to load up. The next component is the local path of where I want to do that mount, in this case var www.html content. I then say that I want to mount it as an NTFS. Now you can mount other file systems like ext4, but then the location would be probably a SDA1 or something like that, would be somewhere on the drive. In this case though, if we specify NFS, it now knows that that's the NFS server. It knows where it's going to be mounted on ours. And then we have some options. First of all, we're going to mount this file system as read-write. So don't forget, we've now got two read-write areas that we need to be careful of. The export needs to be read-write, and so does the read-writable flag in here as well. Then we've got soft, which means if there's an error, it'll abort out. We've got a timeout, which is time before it'll retry if it can't connect, and that's in tenths of a second, so that will be 10 seconds. We've then got INTR, which is interrupt. In other words, we can cancel a mount if need be. And this bit at the end, the dump frequency and pass number, is quite important that it is 00. This is a network file system, not a local file system. So dump frequency is how the dump command would work. And then the pass number is how, if you were doing a file system check, how it would actually check the file system. So they're both set to 0 to say don't do it. If we put that into the FS tab file, we need to test it, and that's where we can do the mount -a to actually test that this command is correct, or this directive in the file is correct. If when we've actually done all that and we mount it, if we actually do a df command, which is disk file systems, and it lists them all, you'll actually find if you'll get your usual home directories mounted onto your SDA1s, etc. But what you're looking for is this bit at the bottom here. You will actually see an NFS mount listed with the connection and specified as NFS4, and it'll tell you where the server is and the client is. So that's a quick way. We're using the mount command with no parameters. We can actually, mount command, that you can look at the file systems on, but the mount command on its own will list up all the mounted file systems. So will df. So where are we getting to at this point? Well, when it comes to the web content storage, what we've actually got is each of the machines, so this is web server 1, web server 2, basically in here, when we actually boot the machine, automatically this folder will be mapped to storage, and this folder will be mapped to storage, but storage actually exists here. So in this server, if you go to var storage, you will see all the files that are loaded by either of the servers, but each server will also see the files that the other server has uploaded. So if a client comes in, or a browser comes in and uploads a file, and the application says store it, it will put it into this location. If the next time they connect, they hit this server and they say read the file, that file will still be available. We've shared the content. Now, that's basically all that is required to get this working. However, what we need to do is think big. All we've done to this point is actually say, here's a web server farm and here's a single point of storage. That's not the end of the story when it comes to file storage. We've used NFS, and even NFS can be distributed by doing block replication on servers. Again, that's something beyond the scope of the module. There's also something called GlusterFS and also Elastic File System, whereby what you can do is you can imagine this infrastructure, which we've currently got one server, as being multiple servers with multiple entry points. So if any one of those servers goes down, the others will take over. So what you would end up with is just like the web server farm part, where if any of these fails, a client would actually end up going to the other servers when they get multiple addresses. if these servers as clients to NFS or file share try to put a file into it and the server isn't available, it would go to another server. So it would distribute the storage. So that's a more advanced topic, but gives us resilience. Now, likewise, we'll be covering database in the next sessions, but we've got a workshop to do just on setting this up first. In there, we'll be using a single database server, but the same applies. There is lots of other technologies out there. There is multiple database servers where you can load balance across them. There's master slave, where one is read writable, the others are read only, and you can actually distribute those as well. So you can end up with different configurations depending on the requirements. If you think about it, something like Facebook, when you actually connect to Facebook and see a picture, I can pretty much guarantee that picture is not stored on one server. It's distributed, but everybody uploads in the same way and the application's only written once. It's all done by the back-end architecture, how it distributes all of the services and how they work. So we're looking currently at just a single server implementation for our network storage, but we need to think bigger than that. There are other ways of doing this. And likewise, when we move on to looking at databases, we should be thinking beyond just the database. Think of them as entry points to another kind of architecture. So from what we've done in this session, what we've done is we've looked at these servers and just the NFS component, but we need to be thinking bigger now. So hopefully what we've got through now is understanding what network content storage is and how it's used. The fact that it's a way of commoning up an area so from multiple servers have a single storage point that is shared. We now know that NFS is networked file systems, and that is a technology that allows us to do it. But we can go further, and there are others. We also know that the server requires clients to be configured to connect to it, and the servers need configured with a certain level of security to allow those clients to connect. The clients in our case are the web servers. So browsers are clients to the web server. The web server is a client to the NFS server. And how does this all relate to web? Well, it's all about putting in high availability systems. If we can put more web servers in, we can handle more clients. And very often the contents of these servers, when they're pulled down to client machines, as in browsers, they are stored and cached. So once you've pulled the file off, if you go back to the server, it's cached. So the idea is you centralize the storage, but optimization is done at the browser layer. We do need to look at how, or you should look at how, this can be actually extended with distributed file systems as well. But that's where it's at. So the best thing to do now is, knowing a bit about the NFS, let's get an NFS share up and running and get the web's clients connected to it, and we'll do that in the workshop.